Bismillahirrahmanirrahim. We are still in this topic, which is the chain rule of the differentiation. The last part we gave some examples about the chain rule, and we said that the chain rule is just a derivative of the composite functions. We are differentiating a composition of two functions. And we said that the chain rule is stated by d by dx of the function is equal to, it is f prime of d of x multiplied by the derivative of the function inside. And we said it is derivative of the composition of two functions, and we gave just picture for this one to make it easier to understand. We said that the function, the composite function, it is like boxes, where the outer one is the outer function and the inside one is the second function. And to find the derivative for this one, we will open the first function, that will be f prime, and keeping g inside as it is. Then multiplied by the second function, we open the second one, which is g prime, and keeping x inside. So if we need to find the derivative, we find the derivative of the outer function, then going inside, from outside, getting inside the composition of the two functions. And we gave some examples. In this part, we are going to give more examples about the chain rule. Find the derivative. Number one, let's see. F of x equal square root of tangent of x square minus 1. Now to find the derivative of this function, we need to know how many functions we have in this example. Because this is composition of different types of functions. If we check this carefully, you will see that we have square root, this is one function. We have tangent, this is another function, and we have x square minus 1, which is another function. So I have three functions, which means I must have three derivatives. By the chain rule, I will find the derivative of the first one is 1 over 2 square root. This is the derivative. This is the function. That one is the derivative. The derivative of the tangent is equal to secant square. The derivative of x square minus 1 is 2x. So the derivative of this function will be the multiplication of the three derivatives. So f prime now can be written as 1 over 2 square root of something there inside. Now derivative of the tangent is secant square. So we have to keep the angle there. Multiplied by the last function, which is 2, the derivative of the last one is 2x. Now inside the square root, we talk about the derivative of the square root only. So the tangent should be there inside without any change. It is x square minus 1. In the second step, we found the derivative of the tangent. So the angle must be there without any change. It is x square minus 1. Then the derivative of the last function, which is x square minus 1, will give me 2x. So this is the derivative using the chain rule. Or just we can write it as cancel this 2 with 2. It will be x multiplied by secant square of x square minus 1 divided by square root of tangent of x square minus 1. So this is the derivative of this function using the chain rule. Another one, number 2. Of x equal to third root of tangent square, and let me take, now this time, x minus 1. Let's make it complicated a little bit. Let's see how many functions we have in this example. So let's just list the functions. The first one is the third root. Second one, I have the square, this square. Third one is tangent. Fourth one, inside the tangent we have another square root. And inside that square root it is 2x minus 1. So you can see that I have 5 functions. I can make the first 2, but I will leave it now as it is. Because we can multiply the power 1/3 by 2 it will be 2 over 3. But I will do it in this way. I have 5 functions. So it means I must have 5 derivatives. The first one, if we differentiate, this is 1/3 to the power 1/3. So the derivative is 1 over 3 to power minus 2 over 3. This is the derivative of the first function, third root of x. It is power 1/3. If we differentiate it, it will be 1 over 3 multiplied by bracket 2 power minus 2 over 3. Now the second one, this one, it is 2 multiplied by something to power 1. The derivative of the third one, tangent, will give me secant square. We have to keep the angle. Fourth one, derivative of the square root is 1 over 2 square root. Last one, 2x, will give me 2. So the derivative will be the product of these 5 derivatives. Let me write all of them now for the function or for the derivative. So the derivative f prime of this function is equal to, the first one was 1/3 to power minus 2 over 3. This is the first derivative. Multiplied by the second derivative, which is the power, it is this one. This is the number 2. So it is 2 multiplied by bracket. I will write it down later on. Then derivative of the tangent is secant, multiplied by secant. And we have to keep the angle inside. The derivative of the angle, which is square root, it is this one now, is 1 over, take this out, it is 1 over 2 square root, and derivative of the last one is 2. You can see number 1, number 2, number 3, number 4, and number 5. These are the 5 derivatives. Now let's fill the blank. Now inside the first one, it is 1/3 to power minus 2 over 3. We differentiate the third root. So the function inside will be as it is, tangent square of square root of 2x minus 1. In the second step, we differentiate the power. So keep the tangent, 2x minus 1. Then we differentiate the tangent, and the angle must be there as it is. 2x minus 1. Then we differentiate the square root, keeping the function inside as it is. It is 2x minus 1. Then we differentiate the last one, which is the derivative of 2x minus 1 will give me 2. These 2 can be cancelled with this one. So the derivative now is equal to, let's bring it at the front, it is 2 over 3 multiplied by tangent square of 2x minus 1 to power minus 2 over 3 multiplied by tangent square root of 2x minus 1 multiplied by secant square. This is secant square. Secant square of 2x minus 1 multiplied by 1 over square root of 2x minus 1. So this is the derivative of this function. Since I have 5 functions, I must have 5 derivatives, and the derivative will be the product of these derivatives. Let me take another one. That will be number 3 now. Okay, let's see the function f of x equal to x squared plus x to power 5 multiplied by sine to power 8, for example, or sine. Let me choose sine to power 8x. Make it easy. You can see for this example that I have multiplication of 2 functions. Multiplication of 2 functions, which means that to find the derivative, I have to apply the product rule first. In the first step, I will apply the product rule. We write it as step 101. Apply the product rule. That is f prime g plus g prime f. The derivative of the first one multiplied by the second plus the derivative of the second one multiplied by the first. So the derivative now in this case f of x is equal to the derivative of the first bracket. You can see that I have 2 functions. I have the power and the function inside the power. So we apply the chain rule for the first function. It is 5 multiplied by something to power 4. That is x squared plus x. Now the derivative of this one is 2x plus 1. This is the derivative of the first part only. It is f prime, or the derivative of the first function. Don't forget that we have another one, which is sine x. Now this is 5 multiplied by x squared plus x to power 4 multiplied by 2x plus 1 times sine to power 8x is the first part of the product rule. It is f prime g. This is only the first part of the product rule. Now for the second part, which is g prime f. So I have to differentiate now the second function. And you can see I have 2 functions. I have the power and I have sine. Now the derivative of sine to power 8 is 8. Differentiate the power first. Multiplied by sine 7x. Multiplied by. We differentiate the power only in the first step. Now I need to differentiate the function sine, because this is what is inside the power. And derivative of sine is equal to cosine x. And this is only the derivative of the second function. Don't forget I have to multiply by the first function, which is multiplied by x squared plus x to the power 5. So this is the derivative. We apply the product and chain rule. So just write it in a good way. I will have 5 x squared plus x to the power 4 multiplied by 2 x plus 1 multiplied by sine to the power 8 x plus derivative of the second function was 8 sine to the power 7 x multiplied by cosine x multiplied by the second function, which is, or the first one, which is x squared plus x to the power 5. So this is the derivative of the given function. Let me take one more. Number 4. That f of x equal to x minus 5 over 3x minus 1. And I need to find the derivative. So we need to apply the chain rule. Chain rule, we will differentiate the power first. It will be 4, keeping what is inside to power 3. That will be x minus 5 divided by 3x minus 1. So we differentiate the power. Now I need to differentiate what is inside the power, this function. But this is quotient rule. So I'm going to apply the quotient rule to find the derivative of the function inside the power. And the quotient rule, as you know, it is f prime g minus g prime f divided by g squared. This is the quotient rule. So the derivative of this function will be now the denominator square, which is 3x minus 1. Now the derivative of the numerator is 1 multiplied by 3x minus 1 minus the derivative of the denominator, which is 3 multiplied by x minus 5. So this is the derivative. We are done from finding the derivative. What is remaining will be only the coordinate algebra. So this can be written in simplest form. It will be 4 multiplied by x minus 5 divided by 3x minus 1 to power 3 multiplied by 3x minus 1 to power 2, and that will be 3x minus 3x. If we just simplify it, this one will cancel this one, and will be minus 1 with plus 5 is equal to plus 4. And this will be the derivative. It is 4 multiplied by x minus 5 over 3x minus 1 on to power 3 multiplied by, sorry, not plus 4, this is plus 14. Plus 14 minus 3 times minus 5 is plus 15, and minus 1, it will be plus 14 divided by 3x minus 1 all squared. It can be simplified more, but that's enough for the derivative. So this is the idea of the chain rule. It is, as we said before, like opening boxes in a chain steps. Open the first one, then go for the inside one and open it, go for the inside one and open it until to get the X there at the end. And this is the idea of the chain rule.